So let's talk about simple and compound interest. And I'm going to share a different screen here. Just a regular screen share. So as we talk about interest and principal and we shift into a financial setting, I want to make sure I'm not blowing past just the basic stuff about what these words mean, in case you're not familiar with them. I think probably principal has to come before interest because principal is what generates interest. And so a simple example would be you put money into a savings account. What's actually happening is you're giving money to the bank, and they can then go do with that, not whatever they want, but they can go invest it in ways that are going to make them money. But since you gave them the money to begin with, they have to pay you something for that, for giving them the money. And typically they pay terrible interest rates, which is kind of a criminal if you ask me, but it's just how little they value your savings investment. On the other flip side of that, if you borrow money, then you're paying a fee to the person you borrowed it from, right? I mean, unless it's grandma and she just says, oh, yeah, I'll give you some money because I know you need to buy a car. I mean, great, grandma, give me some money. But for most people, if they're going to borrow money, it's going to come with a fee. It's not just going to be an interest-free loan. So simple interest, not really worth spending a lot of time talking about. There is a nice kind of reflection of what we have done in terms of this would be a linear model and this would be an exponential model. But it just, because simple interest loans are so rare, I've never heard of a financial institution doing a simple interest loan. The only time I've actually heard of a simple interest loan was when my mother loaned me some money and she charged me interest because she wanted to teach me a lesson about financial responsibility, which is fine. I don't blame her. I think she's a wonderful woman and I appreciate that she tried to teach me that lesson. Didn't work. I had to fall on my face 26 times and get into terrible credit card debt, but eventually I figured it out. Okay, so compound interest is connected to the exponential model, and the most simple example would be something, I'm going to make up some numbers here, but let's say you go to the bank and puts $500 in a savings account, no fees, right? It's another, don't get started on fees. The bank will pay 2% interest. Okay, 2% interest is pretty great for a savings account, honestly. A lot of big bank checking and savings accounts talking about like 0.1%, 0.01%, just absurdly small amounts of interest. Back when the economy was better, 6 months ago, you could definitely find some small banks that would give you 2% interest or even higher, depending on the circumstances, situation, but not unheard of. So how does that connect to the exponential model? Well, I mean, what we have are the two numbers that we need to make an exponential model, which is the starting point and the percent interest. We need to attach to our mind the idea that an interest is supposed to be about an increase, so it's a 2% increase, and so we can make the multiplier. So go ahead and make the exponential model for me. It's exponential, not linear, so it's not y equals mx plus b, it's y equals times to the x. So what's my starting point?
$500.
And then what's what's my multiplier?
1.2.
Careful. Close, but that's 20%.
1.02.
1.02 to the x, okay? So we can kind of map this out. Now, the unstated part here is that 2% would be an APR, which stands for annual percentage rate. So this is what's happening every year. So in year 0, I would have $500. And then from there, I can use my model to kind of map out what's going to happen. So this is 500 times 1.02 to the, and then I'll take my x power there. I'm going to use autofill to finish this. And I can make another column here just to show you what I mean by compound interest. Because if we look at the difference between years, it tells me how much money I earned. Okay, I'm going to turn this all into money. Turn this all into money. So what's happening with compound interest is that as the years go by, if I just let it sit there and let it do its thing, I earn more interest every year. Now, I hope you're saying to yourself, this is not a get-rich-quick program. After 4 years, my $500 has earned a total of $40, which is enough to, I don't know, go out to eat at a not too expensive place. That's 2% interest, and that's like good interest. Let's just see what this looks like at 0.1% interest, just so we can see. Then my multiplier is 1.001, and then I earn 50 cents basically every year. It's such a small amount. It is increasing, but I still haven't gotten over the part of earning 51 cents. It's going to have to wait a couple years to get 51 cents. Okay, I'm gonna poke the banks pretty hard in the next couple of sessions. I got a lot of complaints about banks. I mean, good business if you get into it. If you got a couple $1 million sitting around, you want to start a bank, good business. Okay, so we're not going to dwell too long on this. I just wanted to make the connection between exponential models and the financial section in talking about compound interest. Let me set this back to 2%. There we go. Okay. So where we're headed is the compound interest formula, which is the most complicated formula that you'll use in this class by far. How useful is it? Well, because most of us are going to be indebted and not saving money, it's not super useful from my perspective, my opinion, but anywho. Here is the formula sheet. Okay, so you got to get that out, right? That's the yellow sheet in the middle of your packet. And on the back side, you've got some stuff about interest. You're welcome to use these formulas. I don't really focus on them that hard because from my perspective, if you understand the multiplier and you understand the exponential models, you can do that work without having to like look at these formulas. This formula is the crazy formula we're going to use here. Balance equals principal, parentheses 1 plus hibbity hop. Lots of stuff going on there. So what I'm going to do is I'm going to bring that formula over and do some work on the whiteboard, as I want to talk about filling it out. Let me see. I think there's some good problems here. There we go.
I have a question.
Yeah, go for it.
So when we're dealing with APRs, we are dealing with exponential models.
Yeah, APR is a financial institution thing, and so if you have a question with APR in it, it's got something to do with exponential models. But you can't. It's not that simple. You can't look at a question and say, "Oh, there's APR. I'm going to use the exponential model," because, like in this one, you've got an APR, but you're going to use this compound interest formula. So you got to kind of look at the words and determine what is appropriate. If they're asking you to make a model, then using exponential model makes sense if there's APR involved. But if they're asking you for how much interest or what's the balance going to be, it's probably going to be this crazy formula. Okay, so this is on page 122, and it's a perfect place to start. I always like to tell students to do this calculation on their calculator and see if they can get 138.48, because if you can, then that means you know how to use this correctly to do this. If you can't, something's going wrong. Now, of course, it's much harder to help you when I'm not in the same room as you, but that's a good place to start. Not kind of focusing on how we plug numbers in, but just the calculator usage. So I'm going to give you a minute to see if you can plug in this calculation. All the numbers have been put in place. All you have to do is calculate. What you should come out with is 138.48. If that's not working, see if you can take a picture for me, and I'll try to give you some feedback. After we do that, we're going to talk about actually using the formula.
I got that.
Good. Headed is this $2,000 for 8 years. If you feel like you're ready to tackle it, go for it. If not, I'm going to talk about it in a second. Okay. I hope that worked out okay. If you're struggling with your calculator, let me know. So we're going to take a look at this $2,000, 6%, 8 years. This would be an APR. I don't know why they didn't say the words APR, but that's the intention. And we're going to try to use this crazy formula. So if you look up here, there are 1, 2, 3, 4 pieces of information that need to go in this formula. This is the same phrase, and that's supposed to indicate that it's the same variable. Now, they're not using letters here, they're using words, which is kind of nice because the words should be descriptive of what you're doing. So in this case, $2,000 is the principal. That's how much we're starting with. 6% is my interest rate, but I have to change it to decimal, so there's some work to do there. Not the multiplier, but the decimal. And then the 8 years is provided for me, so it's a number of years, 8 years. Okay, that's good. So then the only thing that's left is this number times comp each year. So what that means, when we spell it out, is it's how many times the interest will be added. So when it's done quarterly, that happens 4 times a year. Sorry, per year. So quarterly would be 4. Monthly would be 12. Daily would be 365. So basically, you're going to use the same formula but you're going to do it 3 times and you're going to get 3 different answers based on how you plugged it in. Let's set the first one up. Principals 2000, that comes first. Parentheses, 1 plus, got my fraction set up. What's the interest rate? I want it as a decimal.
Point zero.
0.06 because it's 6%. And then since it's compound quarterly, this is going to be divided by 4. And then up here, I'm going to do 4 times, because these two numbers are the same. 4 times what? The last number here is the number of years.
8.
4 times 8. Good. Now, a lot of times when I'm advising students about using their calculator, I'll say, just do this part first. Then the rest of it you can do all at once if you have parentheses on your calculator. If you don't have parentheses on your calculator, then you got to kind of break it into parts. Do the parentheses, raise it to the power, then multiply by 2000 at the end. Okay, I'm going to give you a minute to work on that. You're welcome to send me pictures of work. Appreciate the texts people have sent. I'm going to clear this. We'll go to Excel. Kind of organize stuff a little bit. Okay, so there's the first answer for quarterly. Should be about $3,200. So there's some, if you're not coming up with that, then you want to try to figure out, where am I going wrong? One of the things that I saw a student share that's a pretty common mistake, because we've made such a big deal out of the multiplier, is doing 1.06 instead of 0.06, right? But it's the interest rate. It's not the multiplier. You can see the 1 actually is in front, but we first, before we do 1 plus that, we're going to divide it by how many times it's compounded. Lots of places to fall down here. Order of operations errors. So it's really important to get to know your calculator and understand how to use it. Okay, I'm going to do 12 and then I'm going to do 365. Those are the other answers there. I want to find a balance between giving you the support to do this and also not focusing on it more than we need to, because, as I said, it's not super useful in your daily life. I mean, if you have lots of money to invest and sit around in savings accounts or mutual funds or whatever, great. But then you're probably not going to be doing these kinds of calculations, because it doesn't matter that much. But one of the things that this shows, and one of the reasons I like this problem, is it demonstrates that even though it's the same interest rate in the same period of time, one of these techniques comes out on top. One of these number of compoundings is better than the other. It's not like wildly different. They're in the same ballpark, but which one comes out on top? Daily, monthly, or quarterly?
Daily.
Right. So the conceptual thing I want you to understand is that the more something is compound, the better it is for the person earning interest. The real life application of that is when people lend you money, you can tell a little bit about their intentions by figuring out how often they compound the interest. Credit cards are compounded daily. You get a monthly statement, but they're calculating interest every single day. And why are they doing that? Because it's better for them. Car loan, same thing, right? When I look at my car loan day to day, it ticks up every day of the month except the one day that I make a payment. That's because they're adding the interest in every day. Why? Because it's better for them to do that, right? They can still say the same interest rate, but they can make more money if they compound more often.